The quest for extraterrestrial life has propelled countless sci-fi stories and has even fueled missions by NASA. Quite possibly one of the most intriguing spots in this search is Europa, a moon of Jupiter which many believe could hold vital data. Bill Nye, the notable science advocate, is among those who argue for additional investigation of Europa, asserting that this celestial body may be key to unraveling the mysteries of life beyond Earth. NASA's Explorer 1 spacecraft, launched in 1977, made a momentous discovery beyond our solar system. This finding has drawn the attention of some of the brightest minds today, including Bill Nye. What Explorer 1 discovered was ionized gas particles effectively interacting just beyond the heliosphere, the bubble-like region created by solar wind. These readings provided significant insights into what conditions may be like beyond our solar system. Could these be markers of extraterrestrial life? This inquiry has captured the imagination of researchers and space enthusiasts alike. Bill Nye has long been a leading figure in the quest for extraterrestrial life, and his passion for the unknown is evident in his interviews and talks, where he frequently emphasizes the importance of space exploration. The discovery made by Explorer 1 has further fueled this passion, offering new information that might answer the age-old question: are we alone in the universe? To understand why this discovery is so critical, it's essential to look back at the beginnings of space exploration and the events leading up to the launch of Explorer 1. In the mid-1970s, NASA had recently accomplished a monumental achievement by sending humans to the moon. This success ignited worldwide excitement within the academic community, and plans were soon underway to explore much farther into space. NASA's next objective was to study the outer planets of the solar system. However, sending humans on such a mission was not yet practical. The immense distances and the limitations of 1970s technology necessitated reliance on robotic spacecraft for these ambitious explorations. At the time, the Cold War was in full swing, and the US was in a fierce rivalry with the Soviet Union. This competition extended into space, where both countries aimed to demonstrate their technological superiority. The Soviets had made significant strides, launching the first artificial satellite in 1957 and sending the first human, Yuri Gagarin, into space in 1961. However, the US caught up with the Apollo 11 mission in 1969, landing astronauts Neil Armstrong and Buzz Aldrin on the moon. This triumph was a turning point in the space race, but the US realized it couldn't rest on its laurels. The competition with the Soviet Union continued to drive NASA's ambitions to maintain its lead in space exploration. NASA aimed to go beyond the moon, and the goal was now to explore the outer planets. The agency began designing spacecraft that could travel deep into space. One of NASA's first efforts was the Pioneer 10 spacecraft, launched in 1972, which became the first to fly by Jupiter and send back images. Pioneer 11 followed the next year, also heading toward the outer planets. However, NASA needed a more advanced spacecraft that could capture detailed images and data from Jupiter, Saturn, Uranus, and Neptune. This led to the development of the Voyager program. The plan was ambitious, to utilize a rare planetary alignment known as the Grand Tour, which would allow the spacecraft to slingshot from one planet to the next using gravitational forces. This alignment occurs only once every 156 years, enabling NASA to study all the outer planets in a single mission, thus saving both time and money. To achieve this, NASA built two Voyager spacecraft. Voyager 1 was designed to take a shorter route, visiting Jupiter and Saturn, while Voyager 2 would follow a longer path to reach Uranus and Neptune. On August 20th, 1977, Voyager 2 was launched, followed by Voyager 1 on September 5th of the same year. These twin spacecraft would go on to make some of the most astounding discoveries in the history of space exploration. Voyager 1 began capturing images of Jupiter on January 30th, 1979. These photos revealed details of the gas giant that had never been seen before, including its Great Red Spot, a massive storm that has been raging for centuries. However, Voyager 1's mission didn't end there. After completing its flyby of Jupiter, the spacecraft continued on to Saturn, where it sent back even more valuable data. The discoveries made by Voyager 1, especially its detection of ionized gas particles beyond the solar system, have profoundly impacted our understanding of the universe. As the Voyager missions continued to send information from the farthest reaches of space, the quest for extraterrestrial life remained as urgent as ever. Bill Nye and other researchers believe that exploring places like Europa, with its subsurface ocean, could provide the next major breakthrough. What we learn from these missions could change our understanding of life in the universe forever. Every 96 seconds, Voyager 1 captured images and compiled them to create a colored stop-motion video. Using this technique, Voyager 1 was able to send back a film showing 10 rotations of the largest gas giant. By February 10th, Voyager 1 had entered the planet's moon system, sending back film of regular satellites orbiting the gas giant. Before long, it discovered a thin ring of dust and ice surrounding the planet, which was invisible from a distance. This indicated that Saturn was not the only planet surrounded by rings. The ring was only under 30 meters in diameter, puzzling researchers about how little they knew about this planet. By May 5th of that year, Voyager 1 had its closest encounter with the giant planet, separated by a mere distance of 174,000 miles. During this extraordinary event, the spacecraft encountered several of Jupiter's moons, including Io, Europa, Ganymede, and Callisto. The photos it sent back provided incredible insights into the bizarre universe of natural satellites, some of which had very little in common with our moon. These satellites are known as the Galilean moons, named after the astronomer Galileo Galilei, who discovered them in the 17th century. One of the smaller moons seen by Voyager 1 was Amalthea, a reddish and irregularly shaped satellite with a strange surface composition. Images sent by the spacecraft showed that it was made up of ice and silicate materials. The surface became red due to the presence of organic material, and its unusually irregular surface indicates that it has undergone very little internal activity compared to the other satellites. Io was found to be the most geologically active body in the solar system, with many active volcanoes and lava flows visible from its surface. These volcanic activities were triggered by tidal heating caused by Jupiter's immense gravity, making the satellite look more like a volcanic hell's cape than a moon. Europa was most notable for its smooth, icy surface covering a vast expanse of water underneath. Many researchers believe that life could flourish beneath the ice, making the satellite an excellent candidate for extraterrestrial life. A few holes were found on the icy surface, indicating past collisions with space rocks and smaller comets. What followed were images of what appeared to be the largest moon in the solar system, Ganymede. This satellite was so large that it exceeded the planet Mercury in size. It is large enough to have its own magnetic field, and the images showed that its surface was largely covered in rocks and ice. Ganymede's potentially complex geological history continues to astonish researchers to this day, and it probably harbors a liquid core deep within, responsible for its strong magnetic field. Another large satellite observed by the spacecraft was Callisto, the second largest of Jupiter's moons. Its heavily cratered surface indicated a history of continuous impacts with space rocks and a lack of geological activity. Much like Europa, it also has an ocean beneath its surface, making it another candidate for extraterrestrial life. 2 new moons were discovered by the spacecraft and were named Phoebe and Mimas. The images suggested that they are both small and irregularly shaped, much closer to the planet than the other satellites. It is interesting to note that the planet itself and the satellites observed by the spacecraft were named after famous mythological figures. The giant planet was named after the renowned Greco-Roman god of thunder, and the orbiting satellites were named after those who had intimate encounters with him. After the spacecraft's encounter with Jupiter, a course correction was made to prevent it from drifting endlessly across the solar system like the regular satellites. This was done in anticipation of heading towards Saturn about 6 months later. By October of that year, another course adjustment was made to prevent a potential collision with Titan, one of Saturn's moons. The encounter with Saturn was just as spectacular as the previous one with Jupiter, with the spacecraft discovering 5 new moons, a ring system made up of thousands of particles, transient clouds of particles called spokes, and a new ring that couldn't be seen from a distance. It was also found that there were satellites responsible for keeping Saturn's rings as defined as they are. The discoveries of these satellites contributed to the stunning appearance of Saturn's rings. In the coming weeks, Voyager 1 captured stunning photos of Saturn's moons, including Titan, Mimas, Enceladus, Tethys, Dion, and Rhea. The photographs revealed that they were predominantly made of ice, with potential seas beneath, increasing the possibilities of extraterrestrial life flourishing outside Earth. However, those weren't the only discoveries that astonished researchers at NASA. More specifically, the moon Mimas, a relatively small moon, had a unique feature that excited science fiction fans for a long time. This moon had a huge impact crater so wide that it was given the name Herschel. What made it so fascinating was that it made Mimas resemble the Death Star from the famous sci-fi series Star Wars. This intriguing feature indicated extremely low geological activity and a significant past impact with a large asteroid. Other moons observed by the spacecraft were primarily made of ice, with a few distinguishing features separating each of them. However, perhaps the most interesting of the other satellites seen by Voyager 1 was Titan, closely approached by the spacecraft on November 12. At a distance of less than 3,000 miles, the images showed a thick atmosphere that completely obscured the surface. The atmosphere was primarily composed of nitrogen, with the atmospheric pressure equivalent to that at sea level on Earth, but at -300 degrees Fahrenheit. The characteristics of the satellite suggest that it may be the first body in the solar system apart from Earth where liquid could exist on the surface. The chemical reactions necessary for the formation of life appeared to be present on this satellite, with strong indications of significant hydrocarbons required for life to exist. The spacecraft's closest approach to Saturn was on November 12, at under 8,000 miles from the planet. By 1989, all planetary encounters were over for both spacecraft, as all four gas giants had been studied as planned. However, both spacecraft remained operational and were declared part of the Voyager interstellar mission, a venture that formally began on January 1, 1990. The new objective was to go beyond the outer planets of the solar system and, if possible, even beyond the more defined solar system. The specific goal was to gather information on the region of space dominated by Earth's magnetic and solar fields, as well as the interstellar medium. On February 17, 1998, Voyager 1 became the most distant human-made object in existence, surpassing Pioneer 10 at a distance of nearly 70 astronomical units. By September 2017, 45 years after its launch, the spacecraft was still functioning, sending back information from its instruments to NASA's Deep Space Network. Researchers were astonished that the vast cosmic ray telescope and magnetometer still worked properly after more than 40 years in space. Now voyaging into interstellar space, researchers hoped that something out there would notice the message we have sent into the cosmos. As Voyager 1 and Voyager 2 journeyed further from the Sun, their missions took on new significance. Voyager 1 entered interstellar space in August 2012, marking humanity's first journey into this strange region. This achievement gave researchers a unique opportunity to study the conditions of space beyond the heliosphere, the protective bubble surrounding our solar system. Voyager 1's data has been instrumental in understanding the nature of cosmic rays, magnetic fields, and plasma interactions in interstellar space. Voyager 2, in the meantime, continued its mission to explore the outer edges of the solar system and eventually entered interstellar space in November 2018. Its trajectory provided significant comparative data to that of Voyager 1, enhancing our understanding of the solar system's boundary regions. Both spacecraft carry a golden record containing sounds and images intended to depict the diversity of life and culture on Earth. This record serves as a message to any potential extraterrestrial civilizations, showcasing humanity's desire to connect with the universe. As the Voyagers continue their journey, they also contribute to the broader field of astronomy by observing phenomena such as the interstellar medium, the nearby interstellar cloud, and the interaction of solar wind with the cosmic environment. Their discoveries have provided insights into the structure of the heliosphere and the nature of the interstellar magnetic field. The data from both spacecraft is also significant for future interstellar missions. As technology advances, researchers and engineers are studying the Voyager performance to develop new spacecraft capable of traveling even farther into space. This includes potential missions to explore neighboring star systems or to investigate the limits of the Milky Way galaxy. The legacy of the Voyager missions lies not only in their groundbreaking discoveries, but also in their role as forerunners in humanity's deeper exploration of the universe.